We talk about database logging first. So what is database logging? Well, database logging allows me to store any changes I am making to the database. Inserts, updates, deletes, etc. etc. So what is the purpose of logging? Well, when you have to recover information, you can use the logs for that purpose. So there are situations when sometimes there is a crash on the system and your computer goes down. What's going to happen with the things you were doing at the time with the database? Or there may be cases where everything is working fine, but there is a human error and people are inserting incorrect information into the database. How can I recover from the situations? Database logging allows me to pretty much recover from these types of problems and ensures that my data in my database is in a good, consistent state and also contains valid information. Now, logging is always required in DB2. You cannot really turn it off entirely, but you can turn off logging for specific tables or columns. And if you use temporary tables, then you could not log those temporary tables. So let's take a look at this chart to explain logging in a little bit more detail. Actually, let me show you the same chart but using this Paint application. Let's say in this case, I have a table space with a table T1 and a table T2, and this table space is stored on a given disk. Let's say this one, then we have the buffer pool, which is the cache for the database. It is in memory. We have the logs, which are used for recovery, and they are stored on a different disk. Let's say these two. The reason for this is you don't want to store your database information or your database data and the logs which you use to recover that data in case of a crash on the same disk, because if for any reason the disk gets corrupted, then you are corrupting not only the data but also the data that is used to recover the data. That is why you normally want to keep that in separate disk. Now, there are two ways to store information. In the logs, one way is to issue a commit statement. The way I normally explain this is by comparing it to a Word document. So let's say you are working in MS Word and you're writing a nice and important document, and then you ensure that information that you've written is saved on the disk. So you will click on the information you have written so far is saved on the disk. Now you can compare clicking on the save button to issuing a commit statement. When you issue a commit statement, basically whatever you are doing in your transaction at that time, when you issue a commit, you basically save the information into the logs, and that means later on they could be recovered. The other analogy is used with MS Word is that sometimes you are working on MS Word and you are not clicking on the save button. However, at the bottom of your screen when you are working on MS Word, it may save auto-saving. What does that mean? Well, you did not click on the save button but automatically Word is auto-saving some of the information for you. So in the same way, DB2 or a database works like this, where you may not be issuing a commit statement, but that information is still being saved on the logs. Alright, now let's say I have a table T1, and the way it works is in this table I have some record. I'm not going to put the entire record, but let's say the name column has a value of Peter in table T1. Now I'm going to, let's say I'm going to be issuing some statements like update T1 set name equals to Paul, where name equals to Peter, with something like this. I am trying to change the name where the current name is Peter. And what is going to happen is when I issue this command. First of all, DB2 will bring the page from this into memory, because most of the things are processed in memory. So here I am going to bring the page where you have the value of Peter. Then I will perform the change, and now this is going to be changed to say Paul, right? At the same time, in my logs, I will be storing information like this. I will be saying the old value is equal to Peter and the new value is equal to Paul. So these are the types of information I will be storing on my logs, and I can run another update statement like this one. And in this case, I would say update T1 set name equals to Mary, where name equals Paul. So in that case, because I already had the page in memory, I can just simply make the change here and put the new value, which is going to be Mary. And then over here I have another entry where I'm going to put that the old value was Paul and the new value is Mary. So in the logs, I am recording all of this information. In the buffer pool, I just have the latest information, which is the current value for this particular record is Mary. And in the disk on the table space, this information still says Peter. Now this looks like it is inconsistent, but the reason is that we don't need to change the value here right away because we already changed the value. We have already stored this information on the logs. So it does not make sense in terms of performance to the rewriting to the disk to do this twice. So I don't want to write to the logs, which is this, and I don't want to be writing to the table space or this table, which is also on another disk every time that I am doing an update or any other operation, because in terms of performance it will be good. So that's why the way this works, because of the performance reasons. And now let's say I have many pages that I brought to the buffer pool, which is memory. I've been using them, and eventually I want to bring another page to memory. To do the buffer pool, but because most of my pages or because most of my buffer pool contains information that has not been externalized, meaning that the information is not yet reflected on the disk, then I cannot really, these are basically called dirty pages, I cannot really overwrite them. So at that time, there are different methods that will clean this buffer pool for you. So in DB2, for example, we have this parameter called change page. There's should, which is shown here, and by using this parameter, let's say I set it to 80%. What that means is when 80% of my buffer full contains dirty pages, then at the time DB2 will reach this threshold and will flush those pages and externalize them to the disk. Externalize means basically I'm making the information that I had on the table space to be more accurate and more up to date with the information that I had in line buffer pool. So now I had move or change the information here, or externalizing information here, I would say Mary, and then all of this information may be basically or could be deleted because the page that we're using this is no longer required to be there, and it could be used by some other process to bring their pages there. So anyway, in the process, externalization means that the database now has consistent information, and when that happens, when I have here my information in this disk, then some of the logs where contained information are no longer really required for that particular normal processing, because I already have this information stored here. As we will see later, when you have some human errors, it is good to still keep this logs even though they are already externalized on the other disk.